Welcome back, geometry students, to another Regents review video. This is the Geometry Common Core Regents exam for January 2018. 2018, yes. That's how far we are into this Common Core stuff. So these are going to be the solutions to part 1. These are the multiple choice questions, questions 13 through 24, the second half of the multiple choice section of this examination. So, before we begin, as usual, do not cheat off of this video. This is quality content here, and I know that many people want these answers. Do not take them. It is so stupid to do so because you need to know what you're talking about. You need to know what you're talking about in order to do well on this exam. So please don't cheat. It's not worth it. Make sure you hit that subscribe button down below. Consider becoming a patron on my Patreon page and visit my website at www.nysmathregentsprep.com. All of these links can be found in the description below. And I use the TI Inspire CX calculator for this Regents exam, really any math Regents exam. It is the most powerful calculator on the market. I highly recommend it. You'll be using it throughout your entire high school career, possibly college. The links are found on my website, and I think that you'll find it incredibly useful. So we are jumping right now to question 13 of this exam. Unlike the part 1 questions 1 through 12, these are just slightly more challenging but doable. Again, this was a rather easy exam compared to the rest of the Geometry Regents exams. Here we go, number 13. In the diagram below of triangle ABC, DE is parallel to AB. Okay, cool. CD is 15, AD is 9, and AB is 40, so they tell us all of that information. The length of DE is what? So we're looking for this length right here. So a couple things that you need to know about this. DE is parallel to side AB. What is it doing? Well, it's splitting the sides AC and CB. So you're using the side splitter theorem. That's exactly what you're doing. You're applying the side splitter theorem where you're taking the sides and you're setting it in proportion to each other. So here's what we're doing. We're taking 15. We're setting it in proportion to x. And we're taking this whole side and we're setting it in proportion to the 40. So what is the addition of this side? It's 15 plus 9. That's just going to be 24, right? So now we just have to set up a proportion. I usually do like small to small, big to big. Or as long as the sides are corresponding, so you can do small to big, big to small, whatever you want to do. I personally stick with the triangles, like one triangle at a time. So I'm just going to do 15 over x is equal to 24 over 40. That's in proportion. The 15 is in proportion to the 24. The x is in proportion to the 40. We're not breaking any rules with the side splitter theorem. So what I'm going to do is cross multiply. 15 times the 40. And we have 24 times the x. So once we do that, 15 times 40, that's just 600, is equal to 24x. Divide by the 24 on both sides, and you get x is equal to 25. Ladies and gentlemen, that is the answer to this question. Your answer for this is choice 3. Not too bad of a question. Number 14. The line whose equation is 3x minus 5y equals 4 is dilated by a scale factor of 5/3, centered at the origin. Which statement is correct? So first and foremost, it says it's centered at the origin. One of the things that I encourage everyone to do is when you're dilating lines, you have to look at the center of dilation and ensure that the center of dilation is not on the original given line. Because if the center of dilation was on the original line, your image would be that line. It would be the same thing. So just verify. If you take the origin, which is the point 0, 0, and plug it into this equation, well, 3 times 0 is 0. 5 times 0 is 0. 0 minus 0 is 0. Is 0 equal to 4? No, it's not. So that means we know for sure that the origin is not on the original line, meaning that it's actually being dilated. Okay, so far so good. It's dilated. Great. So we know that the image is going to be 5/3 bigger than the original line. So how does this work? Well, let's first go ahead and put this in y equals mx plus b form. So when you do so, you get negative 5y is equal to, I'm going to move that 3x over, so we get negative 3x plus 4. Divide by that negative 5 on both sides, by everything. And we get y is equal to 3/5 x minus 4/5. Here's the deal. I don't care what the y-intercept is. I only care about the slope. Because when you dilate a line, the slopes do not change. They do not change. And the y-intercepts do change. Now, the reason why it's changing in this case is, again, the origin is not on the original given line segment, or line in this case. So we know that the y-intercept is going to change and the slope is not. So if we're looking at which statement is correct, we're looking for something on the lines of the slope is not changing, but the y-intercept is. Let's take a look at choice 1. The image, meaning the result of the transformation that we're performing, which is a dilation. The image of the line has the same slope as the pre-image, but a different y-intercept. Oh, absolutamente. Your answer is choice 1. That is absolutely true. Everything else doesn't make any sense. Good. Answer choice 1. Number 15. Which transformation would not carry a square onto itself? Okay, so here we have a square, right? And what we're doing is we're trying to find the transformation that does not carry it onto itself. In other words, when you take a square and you perform some sort of transformation on that square, which of the following choices does not map the square onto itself? That's what you're looking for. You're looking for what type of transformation where the square doesn't overlap itself. Okay? So it says, for choice 1, a reflection over one of its diagonals. So if we take a square and we just draw some diagonals, right? So in this case, here and here. If you that one's not that great. If you reflect over one of those lines, it's still going to fold onto itself. Everything's perfect. The square maps onto itself. A reflection over one of these diagonals, it's not going to change anything because the diagonals in a square are congruent. They form right angles, so everything about it is perfect. Okay, so that is actually not true. Okay, so that actually does carry the square onto itself. So let's take a look at choice 2. I need to get rid of these things. Choice 2 says a 90-degree rotation clockwise about its center. So that center thing, that center information, that's important. It's rotating around its center 90 degrees clockwise. So it's rotating like this around its center. Isn't that the same thing? Yeah. So it does map onto itself. So that is actually true. So that's not the answer. We're trying to find the one that's not true. A 180-degree rotation about one of its vertices. Okay. So we're taking this little center point and we're moving it to one of its vertices like that. So what happens when you rotate it about one of its vertices? Well, unfortunately, I just don't have the tools on with my mouse to show you how it goes, but I'm going to try my very best to show you somewhat of a representation of what's going on here. So let me just copy the square real quick. And here we go. So we're given this, okay? We are trying to rotate this square around one of its vertices. So when you rotate it, you're rotating it 90 degrees around one of its vertices. So it's going something like this. You're rotating it around once, and then rotating it around again of that vertice. You're rotating it like that. So that is actually what you get if you perform a 180-degree rotation around one of its vertices. As you could clearly tell, the square is not mapping onto itself. So your answer is choice 3. Choice 4 says a reflection over the perpendicular bisector of one side. No. Again, if you take anything that's perpendicular or bisecting the square, it still maps onto itself. If you just, fold it back and forth, it's still going to produce a square that maps onto itself. So your answer for number 15 is going to be choice 3. That was a challenging, in my opinion, challenging question. You really have to be careful of its center of dilation. Number 16, encircle M below. Diameter AC, chords AB and BC, and radius MB are drawn. Which statement is not true? Okay. So you really, really need to know your circle properties in order to get these questions right. You're trying to find the one that's not true. So we know it's a diameter AC, and we have some radii, and we have some chords. Okay. Says for here, choice 1, triangle ABC is a right triangle. ABC is a right triangle. So I assume that they're trying to make this the right angle just because these look acute. Well, let's just verify that information. Is this triangle a right triangle? Well, as you can see here, if you take vertex B and you extend it to A, and then you extend it to C. Okay, so far, angle B is inscribed in using the arc AC. Okay? So again, angle B is inscribed in this circle, and these are the two rays that extend outward from point B. So what are these 2 points intersecting? Well, it's intersecting a hemisphere, okay? Or, sorry, not a hemisphere, because we're not in 3-dimensional. It's a semicircle, okay? So it's half of a circle. So when you have an angle that's inscribed intersecting a semicircle, it forms a 90-degree angle, right? Because if a semicircle is 180 degrees and you have an inscribed angle is always 1/2 the arc it intercepts. If that's 1/2 of 80, this is 90 degrees. So that is absolutely true. It can't be choice 1 because we just concluded that it is a right triangle. And we know that for sure that the points of AC do in fact create a semicircle because they tell you it's a diameter. So we know that that's absolutely true. Look for the one that's not true once again. So the answer is not choice 1. Number 2, triangle ABM is isosceles. Triangle ABM is isosceles. So go ahead and fill it in. ABM. We're looking right here. This is the triangle that we're working with, people. So AM. Well, AM is a radius because it's drawn from the center of the circle to the outs to just the point on the circle. So AM is in fact a radius. It's half of the diameter. And look at this, BM. They tell you that, or MB in this case, it's a radius. Okay. But we don't know what AB is. We don't know what that is. So we're not assuming anything. But is this triangle isosceles? Yeah, it is, because there are 2 sides that are congruent. And you should know this property. All radii drawn from the same center of a circle are, in fact, congruent. So since it is drawn from the same center, it is, in fact, an isosceles triangle. Those are 2 congruent sides. Your answer is not choice 2 so far. All right, let's go on to number 3. Number 3 is telling us that the measure of arc BC is equal to the measure of angle BMC. So we're talking about this. The measure of angle of arc BC is equal to the measure of angle BMC. Well, let's see here. This is called a central angle. And a central angle, in this case, is intercepting arc BC. So you need to know this property. If a central angle is intercepting an arc, the degree measure of that arc is the same degree measure as the central angle and vice versa. So that's actually true. So the measure of angle BMC is actually congruent to the measure of this arc length. So that is absolutely true. Your answer is choice 4. The measure of arc AB is equal to 1/2 the measure of angle ACB. Let's go ahead and verify that information, shall we? So I have the measure of arc AB. The measure of arc AB like that. And it's saying that this arc is 1/2 the measure of angle ACB. So we're looking at this angle over here. Now, some of you might be thinking, wait, Trevor, I got this to be true, and I got one of the other answers. Why is that? Why is this the false statement? Well, you're confusing the number 1/2. So you need to be very careful when you're reading this information. The measure of arc AB is not 1/2 of this angle measurement. So, for example, let's just assume that this angle measurement right here was 30 degrees. What this is saying is that if you take the measure of angle ACB, plug it in there, the 30 degrees, and you multiply that by half, then that means that the measure of arc AB is 15 degrees. That's not true. In fact, what you should be doing is you should be saying to yourself that the measure of arc AB is double the measure of angle ACB. So this 1/2 should actually be a 2 if that was true. Because it's not that the angle measurement is 1/2 of... No, I'm sorry. Let me rephrase that. It's not that the arc length is 1/2 the angle. It's the arc length is double the angle. So that's actually false. This, again, should be a 2 in order for that to be true. So your answer for this question is choice 4. Number 17. I hope that you didn't get fooled with this one. In the diagram below, XS and YR intersect at Z. Segments XY and RS are drawn perpendicular to YR to form right triangles XYZ and SRZ. So we know for a fact that these are right angles thus far. It says, which statement is always true? Always true. So, here we go. Does it say anywhere? Now, if you chose choice 2, if you chose choice 2, you made Trevor very, very upset right now. It is so not choice 2. That is wrong. It doesn't say anywhere in the instructions that Z is a midpoint. It doesn't say anywhere that XY is congruent to RS. It doesn't say anything about line segments. It says everything about angles, though. It says everything about angles. We know that they're right angles. And we also know that they're intersecting each other, so these are vertical angles. Well, all we know is that these two triangles are similar by angle-angle similarity, okay? These are definitely similar by angle-angle. I don't care how congruent they look in the figure. That doesn't matter. That's an assumption. They look really congruent to each other, but we don't know for sure. We have absolutely no indication. And you cannot use a ruler and say, oh, well, it's congruent. No. We don't know that information. So choice 2 is OUT out of here. But we know that they're similar. And similar triangles are in proportion to each other. They're in proportion. So, here's what we do know. That choice 4 is true. Let's talk about why choice 4 is true. So I just said that they're similar. I just said that they're in proportion. Let's verify that this proportion is actually true. The length of XY is in proportion to SR. Yes, those are absolutely true because they're corresponding to each other. Perfect. Now, since XY is the one that started out, the next fraction better have a line segment that's inside of this triangle. Oh, look, it does. YZ is in proportion to RZ. And those are, in fact, proportional because they are corresponding to each other. So this is actually a true statement because they're in proportion. Now, here's why, if you're thinking choice 1, why is it not choice 1? I'll show you right now. Since I just proven to you that these are in proportion to each other, the next thing that you should verify is that the product of the means equals the product of the extremes. So if you actually just simply cross multiply these, that could be another answer. So this is also written as XY times RZ is equal to YZ times SR. Well, if you go over here, XY and SR, no. Look at what they're doing. They're taking this and multiplying it by this, and they're taking this and multiplying it by this. That's not product of the means equals product of the extremes. Product of the means equals product of the extremes means cross multiplication, and that's actually not true. So if you chose that answer, that's what you're confused about. By the way, choice 3, I failed to mention that as well. Choice 3 has nothing to do with the problem because, again, if you pick choice 3, you fell for the trap that these two triangles are congruent to each other. That has nothing to do with the problem. Your answer for this one is choice 4. The triangles are in proportion by corresponding sides of similar triangles are in proportion. A lot of words, but not too bad. Number 18. As shown in the diagram below, the line ABC is parallel to the line EFG, and BF is congruent to EF. Okay, so let's go ahead and label that. BF is congruent to EF. And they're parallel to each other. Great information. They're definitely parallel to each other. Okay. If the measure of angle CBF, so CBF, this angle up here, that's 42.5 degrees, then what is the measure of angle EBF? We're looking for this angle measurement right up here. We're looking for that little angle in the triangle. So there's a couple things that we know for sure. We know that if this is 42.5, then the alternate interior angle down here is also 42.5. So there's a couple things that they're asking you to apply here. They're asking you, do you know how to work with parallel line segments? And do you know the alternate interior angle theorem? And this is an isosceles triangle, folks. Now, since this is, in fact, an isosceles triangle, do you know how to use the isosceles triangle theorem? I hope you do. The isosceles triangle theorem states that if you're given an isosceles triangle, the base angles are congruent, and the sides opposite those base angles are congruent as well. And same thing for the converse. The converse is just switching the order of what I just said. The converse is if you have two sides that are congruent to each other, then the opposite angles of those two congruent sides are congruent as well. In other words, the base angles are congruent. I know, a lot of words that I just said as well. Geometry's a lot of vocabulary here. So, we know that this angle is congruent to this angle. We know that we have a triangle. I'm going to call these both x and x. The reason I could call those x is because they're both the same angle measurement, so we could say that they're both x. We know that to be true. We know that they're the same. They could be the same letter. So, but then we have this 42.5. That's a vertex angle. So, we're trying to solve for x. So, I'm going to just say x plus 42.5. Set that equal to 180 degrees because there's 180 degrees in a triangle. Let's go ahead and solve for x. If we subtract that 42.5 and combine like terms on this side, we get 2x is equal to 137.5. Divide by the 2 on both sides, and we get x is equal to 68.75. Ladies and gentlemen, that is the angle measure for each individual angle. So in this case, they're asking you for the measure of angle EBF. That is 68.75. Your answer for this one is choice 2. Don't be fooled with that 137.5. That is the addition of the two base angles. Your answer is choice 2. Moving on to question 19. A parallelogram must be a rhombus if the diagonals are what? So in a rhombus, there's just a couple things to jog your memory. In a rhombus, the diagonals bisect each other. Okay. In a rhombus, the diagonals are not congruent to each other. That's important. In a rhombus, the diagonals are perpendicular to each other. In a rhombus, the diagonals bisect the angles from which they are drawn. And that's pretty much all you need to know about a rhombus's diagonals. So let's take a look at, see what we're looking for. A parallelogram must be a rhombus. So they're asking you, and this is troubling for most people, they're asking you for the specific property that would make the parallelogram a rhombus. Okay, so in order for it to be a rhombus, what do the diagonals have to do? They have to be perpendicular to each other. They have to be perpendicular to each other. Your answer is choice 4. Now, we know for sure, and I just said this, that they're not congruent. That's a rectangle property. But you're probably thinking to yourself, well, why is it not bisecting each other, Trevor? Well, that's a property of a parallelogram. And this is what confuses the heck out of people. A parallelogram, right? A parallelogram does in fact have diagonals that bisect each other. Same thing for a rhombus. But this answer is too vague because this property is true even for a rectangle and a parallelogram. So it's not specifically saying it's a rhombus. For example, so if I give you a quadrilateral and I say that the diagonals bisect each other, can you necessarily confirm absolutely that it's a rhombus? It can be, sure. It could be a square too. It could be a rectangle. It could also be a parallelogram. But we don't know necessarily for sure that it is a rhombus. So that can't be true. And I just said before that they do bisect its angles. So that's not true either. So your answer for this one is choice 4. Number 20, what is the equation of the line that passes through the point 69 and is perpendicular to the line whose equation is 4x minus 6y equals 15? There's a couple things that you need to know what to do with these types of questions. These are common questions found on all Regents exams. They're asking for the equation of the line that passes through this point and is perpendicular to another line whose equation is 4x minus 6y equals 15. The first step that I want you to realize and what you should understand is take this line right over here, and I want you to calculate the slope of that line. Okay, so in order to do this, you just put this in y equals mx plus b form. So we get negative 6y is equal to negative 4x plus 15. Divide by that negative 6 on both sides. So we get y is equal to, now you can just reduce that fraction a little bit. Two negatives give you a positive answer, and 4/6 reduces to 2/3 x. And I don't really give a darn what the y-intercept is. It just doesn't matter. So we know for a fact that the slope of this line is 2/3. But that's not what we want. We want the slope perpendicular to that line. So if the slope is 2/3, then your second step is to find the negative reciprocal of that slope. So you're taking 2/3 and you're taking the negative reciprocal. That just means you flip the fraction, change the sign. So if you flip the fraction of 2/3, you get 3/2. Change the sign. If it's positive, you get a negative. So this is actually the perpendicular slope. That's your new slope, folks. So now what we need to do is take our new slope and take the point that it's passing through and set up an equation. Well, what's the equation that you should be thinking of? It's the point slope form of a line, which is y minus y1 equals m times x minus x1. Now, honestly, people, most of you don't like that formula, and I know it's so annoying to deal with at probably your age level. But I promise you right now, if you take any sort of higher level mathematics, especially if you take calculus, you are not going to be using y equals mx plus b anymore. You're just not going to do it. So honestly, can you use y equals mx plus b form? Of course you can. You could plug in the negative 3/2, plug it into m, plug in x and y for 6 and 9, solve for b, then rewrite it. It's just so not worth it. And if you even look a little bit closer, all of your answers are in point slope form. It's just not worth doing y equals mx plus b form. So all you need to do is take the 6 and the 9, plug it into x1 and y1 respectively. So you get y minus the y value of 9 is equal to the new slope we have of negative 3/2 times x minus 6. Ladies and gentlemen, that is the answer to this question. And that is corresponding to choice 1. Again, not too bad of a question. Just have to know what you're doing with those with the point slope form and the perpendicular lines. Number 21. These are one of my favorite questions. I love the parallelogram unit or the quadrilaterals unit. Number 21. Quadrilateral ABCD is inscribed in circle O. That is, folks, that is such important information. If you don't know what this is telling you, then you need to download my Facts You Must Know Code for the Regents exam, because this is such an important property that has been tested on the Regents several times thus far. So quadrilateral ABCD is inscribed. You should know by now this theorem. Here we go. If a quadrilateral, meaning any four-sided figure, if a quadrilateral is inscribed, fully inscribed in a circle, that means that every single vertex point of the quadrilateral is actually intersecting somewhere on that circle. So if it is inscribed in a circle, then the opposite angles are in fact supplementary to each other. So knowing this information, we could act, and they give you all these angle measurements down here. That's fine. And we're trying to find which statement is true. So they're asking you to solve for the values of x and y. So since we know this information, we know that we could solve for x and we could solve for y. Now, what's nice about this is we just add up the opposite angles and set it equal to 180 and solve. So we just simply have x minus 10 plus 75 is equal to 180 degrees. Again, if a quadrilateral is inscribed, which it is, in a circle, then the opposite angles are supplementary to each other. Add them up, set them equal to 180, and solve for x and y. So, combine like terms. So we get x, 75 minus 10 is 65, That equals 180 degrees. Subtract the 65 on both sides, you get x is equal to 115 degrees. Okay, so far so good. Now let's solve for y. We get y plus 30 plus 80 is equal to 180 degrees. Combine like terms, you get y plus, let's see, 110 is equal to 180. Subtract that 110 on both sides, and you get y is equal to 70. Okay, so we just got x is equal to 115, y equals 70. Your answer is clearly going to be choice 4 for that question. Again, so not a terrible question. Have to know that specific property. Very important stuff. Moving on to 22. A regular pyramid has a square base. Okay, so let me attempt to draw myself a pyramid with a square base. Now, the word regular means that the bases, or the lengths of the sides of the base are congruent to each other. Okay? Bear with me while I create this pyramid here. It is a regular pyramid. Okay, that's a rough sketch. It looks slanted, but it is, in fact, going to be a regular pyramid in our case. So it says with a base of, so the perimeter of the base is 36 inches. Well, if the perimeter is 36 and it's a square, which has 4 sides, then the perimeter is just 36 inches, which they tell us that in order to solve for the length of each side, you just divide that by 4, and that gives you 9. So that means that each individual side length of the base is 9. Okay? Just by taking the perimeter of 36, divided by 4, which is the amount of sides in a square. Each side is 9. That's good so far. By the way, if you took 36 and you took the square root and you got 6, you just took the area of the base, not the perimeter. So be careful with that stuff. And the height is 15. So the height, let's see here. The height is 15. Okay. What is the volume of the pyramid in cubic inches? Okay. So the volume of the pyramid is 1/3 capital B times the height. Well, you got to know what that capital B stands for. This is all found on your reference sheet, by the way. You don't need to memorize this. The capital B on your reference sheet means the area of the base. Okay? Now, that's important stuff. The volume is 1/3. Well, what's the area of the base? Well, the area of a square is length times width. 9 times 9 is 81. And the height is what we're trying to... Oh, no, I'm sorry. The height we have. We're not trying to solve for that. The height is 15. When you plug all this into your calculator, you get an answer of 405. That's your answer, folks. Your answer for this one is going to be choice 2 for this question. Moving on to the last 2 questions of this exam. 23 says, in the diagram below of triangle ABC, the measure of angle ABC is a right angle. AC is 12, AD is 8, and the altitude BD is drawn. What is the length of BC? The length of BC. Trying to solve for that, X. So you're using the mean proportional. By the way, if this whole thing is 12 and this is 8, CD is the length of 4. That is quite important to solve this question. So if you were just so happening to look at my Facts You Must Know code for the Regents exam, it's that packet on my website. Download it if you haven't already. You'll see I call these 2 different things, but they both mean the same thing. I call it Passois. Most people call it hills. Okay? So what does this mean? Well, Passois, PSSW, that's just really part over the first segment is equal to the first segment over the whole. That's what it represents. And hills, on the other hand, that means hypotenuse over leg 1 is equal to leg 1 over the segment. So what do I mean by all this stuff? Well, if you're using part over segment equals segment over whole, the segment is what is by itself in the lonesome corner of the triangle. Well, what's by itself in the lonesome vicinity of the triangle? It's X. The 4 and the 8 are next to each other, so they're partners, okay? The segment is your X. Now, your part is the segment closest to the segment that's by itself. So this is your part. And your whole, of course, is the whole length of 12. Now, if you're using the Hills method, which is the same thing, it's the hypotenuse. So in this case, it's just a little different, though. The hypotenuse is 12. The leg is x, the leg is x again, and the segment is 4. So all they did is they just manipulated the fractions a little bit, but no big deal. They mean the same thing. Okay, so I'm going to show you both ways just in case you want to know both. So the part is 4. I'm using the PSSW method first. So the part is 4. The segment is x. The segment is x. The whole is 12. Cross multiply and solve. 4 times 12 is 48. That equals x squared. Take the square root of both sides. When you break down radical 48, you should know how to simplify radicals by now. Simplify this. The square root of 48 can be broken down into 16 and 3. The square root of 16 is 4. Radical 3, that is the value of x. Your answer for this one is going to be choice 2 for this question. Now, let's just say you don't like that way and you like the Hills way. It's the hypotenuse, which is 12, over the leg, which is x. That's equal to the leg, which is x, over the segment, which is 4. Again, you get the same answer. I'm not going to do it again, but you get the same answer of choice 2, which is 4 radical 3. Moving on to the last problem. This is, I hate explaining this question because it is quite challenging to explain in English. So 24 says, in the diagram below, 2 concentric circles, meaning that they're circles drawn from the same center point with center O. And radii OC, OD, OCE, and ODF are drawn. If OC is 4, so we're going to label this real quick. OC is 4, OE, the whole thing is 6. Which relationship between the length of arc EF and arc CD is always true? So, honestly, this is going to be so hard to explain. So here's the thing. We know for sure that EF is bigger than CD. I hope that we all could agree on that point. But why, though? Now, most of you might be saying, oh, well, EF, you're just taking the length of arc CD and adding 2 to it because that's what they did to the radius. That's not true. So they are so going to trick you on that. It says, see, like choice 1, the length of EF is 2 units longer than the length of CD. I knew that they were going to throw that at you, but that's not true. We're not talking, there's a big difference here, folks. We're not talking about a segment anymore. We're not talking about a straight line segment. We're talking about an arc. It's a curvature. It's an arc length. So we're not talking about, again, we're not talking about straight line segments. So it's not 2 units longer because, I mean, a unit, really, when you think a unit is straight for line segments. It's not a line segment. You can't just say, oh yeah, it's 2 inches longer than the original. That can't be true. So it has to be a scale factor. That's what we're looking for, a scale factor. We know that EF is actually 1.5 times larger than arc CD. Well, how do I know that? Well, 6 to 4 will help us. Since the radius of the bigger circle is 6 and the radius of the smaller circle is 4, and we know that we're dilating it to get the bigger circle, that's just 6/4, which when you reduce it, that's just the same thing as 3/2, which when you convert to a decimal, that's 1.5 times. So the length of arc EF is 1.5 times the length of arc CD. I hope that made sense to you. Again, it's quite a challenging topic to explain in words, but that is your answer. Your answer is choice 3 for that question. All right, that's the conclusion of this video. Make sure to hit that subscribe button down below. Consider becoming a patron on my Patreon page. I would greatly appreciate it. This is a non-for-profit organization, but I would like to just keep the channel going for so long. I really want to help everyone out. And make sure they visit my website at www.nysmathregentsprep.com. There's so much content on my website that I hope that it helps you throughout all of your mathematical subjects. With that being said, I hope to see you soon.